Hello everyone, my name is Michael Vucic and I will be explaining types of failure in materials and the basic concepts of fracture mechanics. For any material under load, failure of that material can be described as any reaction that makes it unsuitable for its intended use. For example, like cutting the wire of your phone charger. That would make it pretty useless at that point. There are two types of failure we will be analyzing today. One of them is plastic distortion, which is deformation or bending. If we have a material here, this is what it looks like under its maximum load. No any deformation going on here. But as soon as it undergoes plastic distortion, the material will bend, like such. And then, after plastic deformation, fracture will happen, when the material splits in two. As an example, we will consider a tensile loading graph. This is its elongation in percentage. And on the y-axis, we'll consider the stress the material is undergoing. Up until this point, the graph is fairly linear. The amount of elongation is proportional to the stress, right up until it reaches something called the yield strength. At this point, the material will undergo plastic distortion, right up until the point of maximum tensile strength here. After this point, the amount of stress or the amount of load required to bend it further will decrease right up until the point of fracture, when the material breaks. Another thing to add is that materials that deform significantly before fracture are considered ductile. Metals like thin steel shavings or copper, like the door hinge I have here, will deform long before they break apart. And materials that fracture or break without noticeable signs of deforming first are considered brittle, like this popsicle stick that just fractured right there. As you can see, the popsicle stick only showed very small signs of deforming before completely breaking, in fact less than half a second. However, this may not be the case all the time though, as these types of failures can occur in any material given the right circumstances. Some of you may have seen movies where people might freeze steel and then it fractures with one swift blow of a hammer. For example, low temperature in this case. Completely changed the fracture mechanics of this material. And this is what fracture mechanics is, the mechanics of brittle fracture. The approach of fracture mechanics is the assumption that any material will contain a crack of some size. It could be large or small, sometimes not even visible to the naked eye. Just as we saw in this popsicle stick here, when I cracked it, there was a very small crack that first started, and then within half a second, the whole thing completely broke apart. In fracture mechanics, it is believed that brittle fracture occurs because of the load on a given material, causing an assumed crack to spread rapidly in the material, which is what I just showed you. In fracture mechanics, the load on a material is directly related to a stress intensity factor, or K, as we'll be studying. Ki indicates tensile loading. This stress intensity factor is then compared with a critical stress intensity factor, Kc, which is also called fracture toughness, which defines when the crack in the material will expand rapidly, causing fracture. As we can see in our popsicle stick earlier, there was that tiny little crack that formed as the stress increased, that within half a second spread to the entire thing, causing fracture. Failure is considered to happen when the value of K surpasses the critical stress intensity factor. At this point, fracture will happen. I will now show you an example of fracture when K, the stress intensity factor, is more than the critical stress intensity factor, Kc. As you can see here, I have a very thin piece of paper that has a crack in it. This means that its critical stress intensity factor is already very low, which means when I apply stress, it doesn't take long at all for it to fracture. Whereas in this piece of paper, there's a very small crack in it. This means that its Kc value is higher than the piece of paper with the large crack in it. This one is harder to fracture until there. Alright, thank you guys. This concludes me explaining the types of failure in materials and the basic concepts of fracture mechanics. I hope you enjoyed.